If f of x equals the square root of x minus 1 over x minus 1, then the limit as x approaches 1 of f of x equals what? Well, in this case, the first thing we should try, of course, is the analytic method. So the analytic method says take your limit value of 1 in this case and plug that in for x and just see what happens. So the square root of 1 is 1, so 1 minus 1 is 0, and in the denominator we also have 0. So this is the indeterminate form 0 over 0. It doesn't mean that our limit exists, and it doesn't mean that it does exist. It just means that we have to approach it differently if we're going to be able to find out. Now, since we have some square roots involved, the algebra that we use in order to reduce this or change its form in such a way that we can get a result is this. We multiply the numerator and denominator of this fraction by the conjugate. And the conjugate of a binomial is when you take that binomial and you change the sign between it. What happens when you set up a conjugate pair is when you multiply by a conjugate pair, you have the difference of squares. So the difference of squares are really important, and I'll walk through the steps so you see exactly what happens here. But what we get when we take square root of x times square root of x is just x. Square root of x times 1 is square root of x. Negative 1 times square root of x is negative square root of x. Negative 1 times 1 is negative 1. In the denominator, we still have something slightly more complex, and for right now, I'm just going to leave it as is. I'm going to leave this as x minus 1 times the square root of x plus 1. I'm not going to FOIL that out. Now, in the numerator, if you'll notice, I have a positive square root of x and a negative square root of x. Those cancel each other out. And then, what's left in the numerator is just the factor x minus 1, which matches this factor of x minus 1 in the denominator. So that whole factor will just cancel away. Had we multiplied this denominator through, we wouldn't have seen that. So, whoops, there's a 1 there. Now I have the limit as x approaches 1 of just 1 over the square root of x plus 1. And when I plug in my limit value of 1, I have 1 over the square root of 1 plus 1, which is 1/2. And that's a real number, so that's our final answer. And I don't know why I wrote a third there. There we go.